Everyone, welcome back. So we've been talking a lot about microstructures, and now I want to go ahead and see how we would get different microstructures. Let's actually see if we can solve this. So what we have here is a 0.45 weight percent carbon, iron carbon alloy. And we're going to look at the time temperature pass to get the following. So first off, 42% pro-eutectoid ferrite and 58% coarse perlite. The second one would be 50% pine perlite and 50% bainite, 100% martensite, and half and half martensite and austenite. So the first one is the one where it's a bit strange. You're like, well, how in the world did I get 42%? We don't have like 42% lines. Well, it's all coming from its exact composition. So it told you that it had 0.45%. So I'm like right here. This is that line I'll be having for 0.45% on this diagram, which means I have too much ferrite. I'm not where I'm supposed to be. I should be right here. I am actually over here. So I'm going to have more ferrite than I'm supposed to have. This is a hypo-eutectoid composition, and so I would have pro-eutectoid ferrite. Ferrite. So no, that's not an error with the slide. I'm just pulling a slide from earlier, which was a different example. Okay, so if we want to get this, what we need to do is just try to transform everything into perlite, and what we'll find is that what's left over is actually the extra ferrite, this extra austenite that don't then transform. So what I'll do is I'll make sure I'm in that coarse perlite region, which is just below this like red line here. So 680 degrees Celsius, I can just pick a number in there. And I'm going to go all the way across. So when I get here, everything that can turn into perlite has. So 100% of the stuff that can turn into perlite, and I have a lot of austenite left over. When I cool it down all the way finally to room temperature, all that austenite will transform into perlite. Sorry, all that austenite will transform into pro-eutectoid austenite. Or, goodness, ferrite. I can't talk today. And what's the weight percentage? Well, how much you got is just entirely based on your fraction you had at the very beginning. What is a composition or alloy? So, for example, if I want to figure out the weight fraction of perlite at the end, well, it's equal to my carbon concentration minus that like ferrite point, going back one slide, that 0.022. And then I have my eutectoid point minus that ferrite point again. So I fill it in, I see that it's going to be 58% perlite, which leaves me with 42% of the ferrite. So this one was just, it had to be the right composition from the beginning to have that answer. Everything else, though, is just based on temperatures and times. Okay, so let's jump into them. So 50% fine perlite and 50% bainite. So fine perlite is when I'm closer to that line right there. So I want to get closer, probably around 600 degrees Celsius. They said 590. That's close enough, though. I'm going to stay there until I get to that halfway transformed time. So if I'm guessing, that is about a second. Like I'm not going to stay there very long. And then I'm going to cool it again. And I'm going to wait that full time to get the rest of it transformed. As a note, once you've cooled it, it kind of resets your timer. So go back over here to figure out how long you need to hold it. But in the end, we're really just holding it for a decent amount of time to make sure that everything else has had time to transform into bainite. So 50% transformed here, and then 100% of what was left transformed into bainite. That's what you're doing here. You're just seeing how much of what's left is transforming. So give me 50 and 50. Then at the end, you get it back to room temperature. Okay, 100% martensite, just get it quickly to room temperature. Stick it in that ice cold water and hope it doesn't shatter. And then what about 50% martensite and 50% austenite? Here's that thing. So earlier I told you that you can keep the austenite. You can do it if you just cool down quick enough. What I think I forgot to mention, though, is that if you want to keep the austenite, you've got to stay at that temperature forever. Like you can't go any temperature different than 209 degrees Celsius. If you go lower, it will just turn into martensite and disappear. So you have to make sure that you stay at that temperature forever if you want to keep the austenite, which just makes sense. No one wants to have a 209 degrees Celsius hammer, whatever it is, forever. So it will eventually all turn into martensite if you've cooled it down this much. Okay, so that's it for this time. Just trying on a pretty simple example problem. I hope this helps you. I'll see y'all later. Bye-bye.